Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry redox reaction. In this session we are going to see at least 10 questions and more. Come on, let us discuss the first question. Balance the following equation and choose the quantity which is sum of the coefficient of the product. See, usually coefficient means we have to identify balancing equation, right? So here carbon disulfide plus chlorine, it gives carbon tetrachloride plus S2Cl2. Okay, now in this point we have to balance the equation. So balancing that equation here, as we observe here, 4 plus 2, 6 chlorine atoms are available. So 6 chlorine atoms, so 6 chlorine atoms means here only 2 it is available. So that means, can we put it here 3? Suppose if we put it 3 here, 6 chlorine atom, whereas other carbon only 1 it is there. Yes, 2, of course, yes, 2. Is it balanced equation? Yes, balancing. Now, they are asking about sum of the coefficient of the product. See, even in math also, they'll ask about polynomial, coefficient of a polynomial. So, sum of the coefficient of polynomial. Substitute 1 for every variable in the expression. Now, here in this point, number of moles, because we are balancing that equation, no? So, how many moles represents for each? So, here, how many are there? Here, 1, and here also 1. So, they are asking about product only. So, the sum of the coefficient of the product. So, in this chemistry point of view, we are seeing here sum of the coefficient of the product product. So coefficient, how many? 1 plus 1. So it is 2. I hope you got the clarity. So while balancing that equation, you will come to know the coefficient. So that in that way, we can stoichiometric coefficient. That point only here they are mentioning about coefficient. So 1 plus 1, 2. So the answer will be 2. I hope you got the clarity. You are able to balance that equation only. You can identify this kind of sum. Okay. Now another sum also same, just like this. Come on, let us discuss that question. Now second question. Balance the following equation and choose the quantity which is the sum of the coefficient of reactant and product. See, in this question they are asking about both reactants and products. So stoichiometric coefficient. So that means we have to balance the equation. Now, as we observe here, this question, platinum tetrafluoride Pt Cl4 plus Xe F2, it gives Pt F6 plus Cl F plus Xe. Okay, now in this point, fluorine atom, how many are there? Here 6 plus 1, 7 it is there, and chlorine atom only 1 it is there, whereas here 4 it is available. Okay, let us put it 4 over here. So if we put it 4 over here, 4 chlorine atom, whereas fluorine, how many are there? 6. So okay, here 6 plus 4, 10. So fluorine atom, it is 10 atoms are there, right? Now that means here only 2 it is available. Okay, now that means here 10, no? Let us put it 5. 5 2s are 10, no? So 5 2s are 10. Yes, fluorine atom, it is 5 2s are 10. So 10 fluorine atoms are available. Okay, that means here 5. So I think, is it balanced, that equation? Yes, platinum 1 only it is there. Here also 1, right? Okay, so that means now we have to find the coefficient, sum of the coefficient of reactant and product overall. So that means stoichiometric coefficient only, right? So here 1 pt Cl4, right? 1 pt Cl4 plus 5 Xef2, right? It gives 1 PtF6 plus 4 ClF plus 5 Xe, right? Now in this point, here 1 and 5, here 1 and 4 and 5. So that means 1 plus 5 plus 1 plus 4 plus 5. So altogether, how many? 16. So the sum of the coefficient of reactants and products of this equation, it is 16. I hope you got the clarity. Suppose if they are asking such kind of question, sum of the coefficient, yes, sum of the coefficient of reactants and products, you better check the balancing equation. So stoichiometric coefficient only they are asking. I hope you got the clarity of both the question. Come on, let's go to the next question. At 0.1 mole, H3POX is completely neutralized by 5.6 gram KOH. Then select the true statement. So this X, we have to identify whether it is X equal to 3 or X equal to 4 or X equal to 2 or all of these. Right. Now here, before finding this, let us write the equation so that it will get some clarity. So here what it is? X. What it is H3POX plus KOH. Actually, this is what it is. H3POX plus KOH, acid and base. You are getting salt and water, 100%. Right now here, they have given it is actually 0.1 mole. Right, so here also we have to find the number of moles. Here what it is, they have given 5.6 gram of given mass. It is 5.6 gram of KOH. So number of moles we have to identify. Number of moles of KOH. KOH, what is the molecular mass of KOH? Potassium 39 and oxygen 16 plus hydrogen 1. So altogether it is 56 gram per mole, right? Right. So here that means given mass 5.6, molecular mass 56 gram per mole, and here gram. So gram cancel. So here what it is? 0.1 mole. So that is here also zero point 0.1 mole. So here also zero point 0.1 mole, here also zero point 0.1 mole. So both are zero point 0.1 only. That means here what it is balancing, it will be easy for us. Right now here what it is, what is the salt you will be getting? KH2POX plus H2O. So this is a product. So how many oxygens are there? How many hydrogens are there? And how many potassium? So potassium is only one, so only one potassium is available. H2, how many are here? H3 plus 1, 4 it is there. So here 2 plus here 2, 4 it is available. Oxygen only we have to identify. So oxygen what it is? Here what it is? O, 1 is there, here also 1. But over here also what it is? Here 1 and here also 1 only here available, right? So that means let us put 2 over here. Suppose if we put it 2 over here, here actually 2 plus 1 3 H2O, exactly it will be 1 oxygen only. Whereas here if we put it 2 over here, here also we can put it 2. So that means if we put it 2, 2 plus 1 3, here also 2 plus 1 3. Okay, they are asking about what it is, 0.1 mole, 0.1 mole. So both it has to be equal. So as we observe here 1 mole and here 1 mole, so naturally it is balanced. So 3 plus hydrogen, 4 hydrogen, here also 4 hydrogen is available. Oxygen 3 means here 2 and here 2, that means here 3 and here 3. Hydrogen also 4. Phosphorus, yes, of course it is only 1, right? Now so if they are asking such kind of question, so x equal to what it is? 2 only. Actually KH2PO2, it is not an acid salt. Actually, why you know? Because it is a monobasic. N factor, it is 1. Here N factor, actually it is 1. Why N factor 1? Because only one electron it is passing. So in that way, that is one hydrogen atom in the acid is ionizable. That is what I just mentioned here. So ionizable acidic hydrogen, only one is available. So H plus HPO2 minus, in that way. So what is the correct option? X equal to 2. So here x equal to 2. The given acid does not form acid salt. This is not an acid salt at all. So actually here KOH, it is a monobasic. Okay, this is actually monobasic. Strong base. N factor, it is actually 1. And the same way H2PO2 also, here that N factor, it is only 1. It is only one acid hydrogen ionizable. So hydrogen, only one hydrogen atom in the acid is ionizable. So that is acidic. I hope you got the clarity. See, that is what I just mentioned. When you write the equation, you will get that idea how to balance. See, balancing equation, indirectly how they are asking about. I hope you got the clarity about this question. Come on, let's go to the next question. Question: when potassium permanganate is titrated against ferrous ammonium sulfate, FAS, in that practical lab you might have done this, potassium permanganate versus FAS, ferrous ammonium sulfate, more salt, no, that is in acidic medium, the equivalent mass of potassium permanganate. This is very simple. Equivalent mass, how to identify? So equivalent mass equal to equivalent mass equal to molecular mass by number of electron change. So what is it? Number of electron change, whether number of electrons losing or gaining, or H plus ions, it is replacing H plus or OH minus ions replacing. In that way also we can identify. So generally we can say N factor, right? N factor. So N factor only we can identify what it is, number of electron change, right? Now in this point, potassium permanganate they are asking about. Okay, so potassium permanganate KMnO4. So here we can take that ion exchange, right? So here MnO4 minus, it has converted to Mn2 plus. So FAS, no, this is FAS, ferrous ammonium sulfate, more salt, no. So how many electrons change in that? Here actually what it is, 4 oxygen, no. So here minus 2, so it means minus 8. Minus 8 equal to plus 1. So here minus 1, right? So plus, this is x. So x equal to what it is? Plus 7. So this is plus 7, which is converted to plus 2, right? So that means how many electrons change? Here 5 electrons change. So equivalent mass, just now I just mentioned, no? So equivalent mass equal to what it is? Molecular mass divided by 5. So this is the way we can identify equivalent mass. I hope you got the clarity. How do we identify equivalent mass? Equivalent mass is nothing, molecular mass by number of electron change while doing for the redox reaction. Okay, so that means which is the correct option? Option B is the correct option. Option B is the correct option. I hope you got the clarity about what is equivalent mass and how to identify the N factor also, right? Come on, let us go to the next question. Equivalent mass of FeS2 in half reaction, FeS2, it gives Fe2O3 plus SO2. Right now, here, let us write this equation. FeS2 plus oxygen, it gives Fe2O3 plus SO2. Right. Now, in this point, here minus 1, here plus 2 oxidation state. Whereas here, of course, it is 0. Right now, here, this is actually plus 3 oxidation state because ferric oxide here minus 6 no, so here divided by 2, here plus 3 oxidation state. Okay, sulfur here what it is, so here minus 2, so this which is converted to plus 4 oxidation, so here minus 4 means here plus 4 oxidation state. So in this point iron Fe plus 2 converted into plus 3, right? So plus 3 oxidation state, so it is electron change, it is 1 electron change. Whereas sulfur, it is sulfur when we are talking about here minus 1 which is converted to plus 4 oxidation state, right? So that means here minus 1 plus 4, so how many electrons, it is plus 4 minus minus 1. Okay, so that into 2, because here 2 atoms are available, no, so here 2, so altogether this is plus 5 into 2, so you will get 10. So 10 electrons change in sulfur, right? So 10 electrons change plus iron, how many electron change? 1. So that means altogether 11 electron change. So equivalent mass of FeS2, they mentioned, no, so FeS2, 2 atoms, that is what I multiplied by 2. So that means here what it is, FeS2 of equivalent mass. So that means equivalent mass equal to what it is? Molecular mass by number of electrons change. So that means M by 11. So this option B is the correct option. I hope you got the concept and clarity about these two questions. Equivalent mass, when they are asking, please go to the molecular mass divided by number of electron change, whether it is gaining or losing. In that way we have to identify, that is n factor. So molecular mass by n factor, that is equivalent mass. I hope you got the clarity. How do we get this answer? Come on, let's go to the next question. Equivalent mass of HCl in the given reaction K2Cr2O7 plus 14 HCl, it gives 2 KCl plus 2 CrCl3 plus 3 Cl2 plus H2O. The same idea only. Equivalent mass equal to molecular mass by number of electron change, that is n factor. Come on, let us discuss this question. Actually this question equation only we have to consider, balanced equation only they have given, so in that way only we have to identify. Okay, now that means K2Cr2O7 plus 14 HCl, it gives 2 KCl plus 2 CrCl3 plus 3 Cl2 plus H2O. Right, now oxidation state, let us identify. So here actually what it is, this is, you know very well, this is minus 14, right? So that means this is plus 2 plus 1, no, so that is K2 is a plus 2, so naturally you will get what it is, 12, so 12 divided by 2, so you will get what it is, plus 6 oxidation state. Whereas here minus 1 plus 1 only, so this is plus 1, this is minus 1, you know very well, right? So in this point, so here also minus 1 and this is plus 1, right? And the same way here, this is actually plus 3 chromium, plus 3 oxidation state. Of course this is minus 3, but here plus 1, minus 1 only, so this is actually minus 1. I just mentioned chlorine atom, but here minus 3 only. So here actually 0 chlorine, it is what it is, Cl2, no, so this is 0 oxidation state. Of course this is what it is, plus 2 minus 2, right? Okay, now let us discuss both together, HCl and K2Cr2O7. So K2Cr2O7, it gives actually what it is, 2 CrCl3. So this is actually plus 3 oxidation state, this is plus 6 oxidation state. Main thing we can consider. Okay, so plus 6 which is converted to plus 3, that means each chromium atom plus 6. Okay, now the next one, HCl. So here actually what it is, 14 HCl. So 14 HCl only we have to consider. Only HCl we cannot consider. We have to consider it is a stoichiometric coefficient, like balancing equation only we have to identify. So that means here what are the things we can observe? 2 KCl, where and all Cl it is coming, that and also we have to identify. Plus here 2 CrCl3 plus 3 Cl2. Right, now here this is minus 1 and this is plus 1, right? So this is minus 1 and I'm saying that atoms point. Okay, now in this here also minus 1 and this is plus 1, and the same way here also minus 3, that is minus 1 only. So here actually 0. So minus 1 which is converted to 0, that point only we have to consider. Here also what it is, minus 1, here also minus 1, but here what it is, completely losing. So how many electrons it is losing? 6 electrons it donated, so which is converted, minus 1 which is converted to 0, right? So that means how many electrons it donates, that means losing. So it donates 6 electrons. So donates 6 electrons. So number of electron change, in that way we have to identify. So equivalent mass equal to molecular mass by n factor, right? Equivalent mass equal to molecular mass by n factor. factor. So n factor. So here one more point also I would like to mention. How do we identify that n factor? Okay, I just bring that sum. So here 14 HCl I just mentioned. No, so 14 HCl. So complete 14 HCl of that molecular mass only we have to bring. Why? Because this is a balancing equation while calculating that sum, so that we have to bring it in that way. So 14 into molecular mass of HCl 36.5. So 14 into 36.5 you will get 511.0. This is okay. So here molecular mass of 14 into 36.5. So here 511 divided by n factor. How much we got it? Here 6 electrons, right? So here 6. So that means when calculating here 6 ones are 6. 6 eights are 48. No, so 48. 6 eights are 48. 8 and then here 1 and 2 3. So that means 6 5. 6 fives are then remaining 1. So again 1 6 are 6. So 85.1 as the correct answer for equivalent mass. They are asking about equivalent mass. Okay, this is one way we are bringing the answer. So the answer what it is 85.1. Yes, answer D is 85.1. Yes, we got it. One more idea also I would like to bring it here. N factor you are bringing in this way. Okay, now n factor is equal to electrons, that is number of electrons, right? Number of electrons change divided by stoichiometric coefficient. Stoichiometric metric coefficient. Right. So stoichiometric coefficient. So number of electrons change, how much it is? 6, right? Number of electrons change, it is 6 divided by stoichiometric coefficient, that is 14 HCl, right? 14 HCl. So 14 HCl means divided by 14. So how will you get it here? What it is? 2. If you are going for 2, that means 2 3s are 6. Here 7 2s are 14. So 3 by 7. Okay, now the same answer you just bring it over here. So that means here 36 molecular mass of HCl. Molecular mass of HCl. Molecular mass of HCl 36.5 divided by what it is? N factor, right? So n factor what it is? 3 by 7. So 3 by 7. The 7 will go upwards. So 7. So 36.5 into 7 divided by 3. So when you calculate this, you will get 85.1 only you will get it, right? So 85.1 only you will get. That is equivalent mass. I just mentioned directly. What is it directly? Here, n factor, what it is? Equivalent mass equal to molecular mass by n factor. So molecular mass by n factor here, complete stoichiometric balanced equation. How many moles of HCl? That only I directly multiplied with that. See, 14 into 36.5. So that is actually molecular mass. I just brought it. So molecular mass by number of electrons change, that is n factor. So 511 divided by 6, you are getting what it is? 85.1. So in this way also n factor, what do you mean by n factor? Number of electron change divided by stoichiometric coefficient. Stoichiometric coefficient, what it is? 14 HCl. In the question it has mentioned. So in that way also you bring n factor. This is another statement what it is. N factor means what it is? Number of electrons exchange. So that means n factor, how do we bring it? Number of electrons change divided by stoichiometric coefficient. In that way also you can bring. So if you go this way, you are getting the same idea. Molecular mass of HCl, it is 36.5 into 7 divided by 3. Why did I put it 7 by 3? Here just what it is, reversible, right? So 3 by 7, 7 will go upwards. I hope you got the complete idea about this question. Come on, let's go to the next question. The answer is 85.1. Come on. Can also related to that equivalent mass of H3PO2, hypophosphoric acid. Phosphenic acid also we can say phosphoric acid. Hypophosphoric acid, H3PO2, when it is disproportionate into pH3 and H3PO3. So what is the answer? Come on, let us write the equation. So H3PO3, right? So H3PO2, it gives here what it is? pH3 plus H3PO3. Balancing this equation here, actually if we put it 3 over here, here 2. Okay, now balancing that equation. Now in that, right, now here actually minus 4, no, so here plus 3. So here you will get what it is? Plus 1 oxidation state. And the same way this is plus 3. So this is minus 3 oxidation state. Right now here this is minus 6. Right now this is plus 3 and this is plus 3 oxidation state. Right. Okay. Now let us write each one so that it will be easy for us to identify. So H3PO2, that is 3H3PO2. It gives what it is? First one, 2H3PO3. So here how many electrons change? Here plus 1 oxidation, which is converted to here in this point. Here plus 3 oxidation. So plus 1, which is converted to plus 3. So how many electrons exchange? Here 2 electrons change. And the same way phosphine, no, H3PO2, which is converted to phosphine, pH3. So pH3, here what it is, +1 oxidation state, which is converted to here -3 oxidation state. So how many electrons change? It is +1. So this is +1, 0, -1, -2, -3. So in that way, how many? 1, 2, 3, 4. So 4 electrons change, like we are going this interior way. Okay, now in that way, so here 2 electrons change and here 4 electrons change. So equivalent total mass, that is total equivalent mass, total, because both we have to consider. No, this also we have to consider, phosphine also we have to consider, and H3PO3 also we have to consider. So that means total equivalent mass, right? So molecular mass by n factor. No, so that means molecular mass, that is m by 2 electron plus m by 4 electrons. So 4 electrons, right? So 4 electrons. So that means altogether when we take that LCM, so you will get what it is. If you take the LCM 2 and 4 LCM, right? So 2 and 4, you will get what it is. The answer will be here 3m by 4. You will get 3m by 4. The answer will be what it is, 3m by 4. Yes, 3m by 4. D, option D is the correct option. So see, in this they did not ask anything about coefficient, that is what it is, stoichiometric coefficient equation they did not provide. We only balanced. So what they are asking, disproportionate, like, so that is what we are mentioning about both this and this, providing these two. So together, what it is, equivalent mass. So molecular mass by n factor. So molecular mass by n factor, total equivalent mass. So that is what we are going for. What it is, 3m by 4. M, it is what is it? What is it? Molecular mass. So molecular mass by n factor. So 3 into m divided by 4. Hope you got the clarity. Okay, now the next question. In the following reaction, AS2S3 plus H plus NO3 minus it gives NO plus H2O plus ASO4 3 minus plus SO4 2 minus. This is also another one more. They have given the equation only. We have to find the answer only for equivalent mass of AS2 S3 is related to its molecular mass by. See, very clearly they have mentioned. I just to bring it to you here. And this point, I hope this question it's clear for you. Come on, let's go to that next question. And this point here, what they have mentioned, AS2 S3 plus H plus plus NO3 minus it gives NO plus H2O plus ASO4 3 minus plus SO4 2 minus plus SO4 2 minus. Okay, come on, let us identify that half reaction in that. Okay, now in the AS2 S3, it gives what it is, ASO4, right? ASO4 3 minus. Okay, now let us check the oxidation state. So in this, actually what it is, sulfur, it is actually -6. So that means here what it is, +3 oxidation state, it is +3. How do we get +3? Here +6 only, divided by 2, +3, right? Now in this point here, what it is, here -8 equal to +3. So that means x equal to what it is, +5 oxidation state. So this is +3 which is converted to +5. Okay, so +3 which is converted to +5. So how many electrons change here, which is converted to +5? So 2 electron change. And how many atoms? It is 2. So 2 into 2 electron change. So that means 4 electrons totally, right? Okay, now the next one, what it is, here AS2 S3, it gives SO4 2 minus. Now we have to consider SO4 2 minus. Now in the question, what they are asking, equivalent mass of AS2 S3. So that's what we are bringing this point. So AS2O4 1 point, the other one AS2 S3 sulfate ion also it brings. So that is what we are bringing this point over here. Right now here, what it is, oxidation state, it is -2, right? So here -2 which is converted to here -2, sulfur ion, it is -2, right? So here what it is, -8, which is equivalent to +2. So that means what it is, +6. So +2 which is converted to, see actually here -2 which is converted to +3. So that means -2 which is converted to +6 oxidation state, right? So how many electrons change? So here the number of electrons change, actually 6 minus -2, right? So 6 minus -2, so 6 minus -2. So it is actually into number of atoms, how many? 3. So here what it is, 6 minus -2, that means into. That means here minus into minus plus. So +8 into 3. So altogether 8 3s are 24. I hope you got the clarity. How do we get 8 electrons? Here 6 electrons minus. So that is actually electrons change, -2 which is converted to +6. That means from here we have to minus 2. So 6 minus -2 into 3. What is it? 3 number of atoms to all together. So how do we convert here? This is also the same. So all together what it is? 24. So 24 electrons change. Here 24 electron, here 4 electrons. So all together here 28 electrons. So 28 electrons. So equivalent mass, total number of electrons transfer, it is 24 electrons. Sorry, 28 electrons. So equivalent mass of As to S3. So this is what it is, molecular mass divided by 28 electrons. So 28 electrons. So M by 28. I hope you got the clarity. How do we go for it? I just bring it directly to you. So M by 28. So this is the correct option, M by 28. I hope you got the clarity about these two questions. This is actually JEE mains question, so that I just bring it to you. Come on, let's go to the next question. Sulfur forms the chlorides S2Cl2 and SCl2. The equivalent mass of sulfur in SCl2. See the question, how they are asking equivalent mass of sulfur in SCl2 only they are asking. Okay, now equivalent mass of sulfur in SCl2. That is what they are asking. Okay, now let us check atomic mass of sulfur, what it is. Atomic mass of sulfur, it is 32 gram per mole. You know very well. Right now in this valency also we have to check it. Valency of sulfur in SCl2. So valency of sulfur in SCl2, what it is. So here sulfur forms in two things, right? So sulfur forms in two bonds with that chlorine atom. So the valency it will be 2 only. So valency of sulfur, it is 2 only, because it is SCl2, no? So 2 bonds, so naturally it will be 2. So equivalent mass, I just bring it. Suppose if they are asking molecular mass, equivalent mass equal to molecular mass by number of electrons change, or valency. Now here equivalent mass of sulfur only they are asking. So I'm giving that statement here. Atomic mass by valency. This is another statement. This is another what it is, formula to find the sum easily. That's what I just bring it here for you. So in this point, what it is, equivalent mass, suppose if they are asking a specific atom, so equivalent mass equal to atomic mass by valency. So atomic mass by valency, what it is, what is the sulfur atomic mass? Sulfur atomic mass, it is 32 gram per mole, and the valency, it is 2. Just now we mentioned in this form, SCl2, 2 bonds it is making. So that means naturally 2. So that means what it is, 16. So 16 gram per equivalent. Right now, which is the correct option? 16 gram per equivalent in sulfur SCl2. So here, which is the correct option? Option B is the correct option. 16 gram per mole equivalent, right? So equivalent mass only they are asking. So equivalent I just mentioned. I hope you got the clarity of this question. Come on, let's go to the next question. Here only it is the next question also. The equivalent mass of an element is 4. Its chloride has vapor density. See, again the vapor density is another one important hike. Right now, vapor density 59.25. Then the valency of the element. This is very simple. You have learned very clearly, right? Okay, come on, let's go for it. First, we'll go for the statement so that it will be easy for us to identify. So here, molecular mass equal to 2 into vapor density. 2 into vapor density, this is one statement, right? Now another statement, vapor density, Vd is it, vapor density. So vapor density equal to molecular mass by 2. This is another statement. This is another formula. This is very, very important formula both. Okay, so this is molecular mass. So this is 2. Why do we bring it here? Mass of hydrogen, H2. So that is what we bring. Molecular mass, usually when we are going for vapor density, these two formulas commonly they will ask. Molecular mass equal to 2 into vapor density. Vapor density when we are bringing out, so that molecular mass by 2. Okay, now in this question, they are asking about very clearly here what it is, equivalent mass. Right here, equivalent mass of the element, it is 4, and chloride has the vapor density 59.25. Then the valency of the element. Now they are asking about the valency of the element. Okay, come on, let us find out. So here, molecular mass of the metal chloride. So molecular mass of the metal chloride we have to identify. For that, molecular mass of metal chloride equal to sum of the atomic mass plus what it is, atomic mass of chlorine, sum of the atomic mass and atomic mass of chlorine. Right. Okay. Now here molecular mass of MCl. Right. I just mentioned molecular mass of M. That is metal chloride. That is valency. I just mentioned. We did not know that is whether MCl2 or MCl4. That MCl3 we did not know. So that I just mentioned valency. V, it is valency equal to atomic mass plus valency. That is valency into atomic mass of chlorine. Atomic mass of chlorine. Right. So this atomic mass, it is metal and valency. This is this valency, atomic mass plus valency into atomic mass of chlorine. So this is metal divalent like that and all it is there. No, so in that way for that. Okay. So equivalent here what it is in this point, molecular mass equal to 2 into vapor density, right? 2 into vapor density. So 2 into 59.25. So you will get what it is 118.5 you're getting. So molecular mass, it is 108. We got it 1 point. So 108, it is molecular. So molecular mass. So 108.5 equal to, it is actually molecular mass we got it. Now how do we go for it? Equivalent weight into valency plus valency into what it is, atomic mass of chlorine. So here valency equivalent mass, how much they have given? Equivalent mass, it is 4 they have given. No, so equivalent mass into valency plus valency into atomic mass of chlorine. So atomic mass of chlorine, so here I just bring it here. Equivalent mass, what it is? Equivalent mass, it is 4 into V plus V into atomic mass, what it is? 35.5. So here when we are calculating this, here 4V plus 35.5V equal to 118.5. So 18.5 equal to 39. So when we calculate it is what it is? 39, right? Here 39.5 B. So 118.5 equal to 39.5 B. Therefore, B equal to 118.5 divided by 39.5. So altogether 3. So this is actually valency only we are calculating. I hope you got the clarity. How do we identify that valency, equivalent mass, molecular mass, all these concepts? Come on, let me give you idea. So what is the valency? It is 3. Option, let us check it. Then we can bring the concept over here. So the answer it is, and the answer 333. Yes, we got that answer 3. I hope you got the clarity. Option B, 3 is the correct option. I hope you got the clarity about equivalent mass. How do we identify? Suppose if they are asking equivalent mass, molecular mass by what it is, number of electrons change. Now here vapor density they are giving. So vapor density in that point, what it is, molecular mass equal to 2 into vapor density. So vapor density equal to what it is, molecular mass by 2. Suppose molecular mass of a specific atom, if they are asking atomic mass by valency. So these are all the ideas we just bring it to you. Yes, come on, let's go to the next question. 6 into 10 to the power of minus 3 mole K2Cr2O7 reacts completely with 9 into 10 to the power of minus 3 mole X power n plus to give XO3 minus and Cr3 plus. The value of n. So this n only we have to identify for this. Right. Yeah, come on. Let us check this question. Equation, let us find first of all. K2Cr2O7. So K2Cr2O7 plus X nth power n plus this is okay. Now you are getting what it is, XO3 minus plus Cr3 plus actually. So Cr, no, here 2 you will get it. Okay, now let us check the oxidation state. Here minus 14, right? This is minus 14, this is plus 2 plus 1 on this, so here 2. So altogether here what it is, plus 6 oxidation state. How do we get plus 6 here? Minus 14 minus 2 here, 12 divided by 2, this number of atoms. So you will get plus 6 oxidation state. Right now here in this point here what it is, plus 6 which is converted to plus 3. So plus 6 which is converted to plus 3 oxidation state. Now in this point how many moles they have given? No, so let us consider here what it is, 6 into 10 to the power of minus 3 mole, right? So 6 into 10 to the power of minus 3 mole. Here 9 into 10 to the power of minus 3 mole, right? Right now this only we have to identify. Okay, now in this point here what it is, number of electrons change. Here 6, here 3. That what it is, each chromium atom 3. So that means how many electrons change? 6 electrons change. See, per chromium it is 3, another chromium, so each chromium it is 3. So that means 6 electrons change. It is 6 electrons change. The other one, this point, and this point what it is, X to the power n. So X to the power n, here what it is, here 3. That means minus 6 equal to plus 1. So that means X equal to this metal, right? So this is actually plus 5. So here n, number of electrons exchange, that means 5 minus n. Can we bring it here? Why? Because we did not know this is n. This n we did not know. That is what, this is 5 electrons. It is whether increased or decreased we did not know. But 5 minus n I just bring. So number of electrons change, it is this point 5 minus n electrons. Right now let us check the calculation part. So here equivalent equivalent weight of that K2Cr2O7, right? So equivalent mass of K2Cr2O7 equal to equivalent mass of x to the power n plus, right? So this and this, actually it will be easy because oxidation and reduction, both it has to be equal, right? So that is what I just mentioned here, this point. So oxidizing equivalent mass is equivalent to reducing equivalent mass. Okay, oxidizing equivalent mass equal to reducing equivalent mass. These are all the concept ideas so that we can bring this point to bring the conclusion, right? Okay, so here one more point I just bring it. So mole into n factor. So n factor we found that what it is, 6 electron we found, 1 K2Cr2O7, and for this 5 electron minus n we brought it. This is for 6 electron, this is for what it is, 5 electron minus n, right? Now here mole also we brought it, so we bring, because they have mentioned mole, right? So mole into n factor, mole into n factor. So mole into n factor, if we are bringing 6 into 10 to the power of minus 3 into 6 electron, right? Electrons change of K2Cr2O7. I just bring according to this idea. So 6 into 10 to the power of minus 3 into 6 electron equal to 9 into 10 to the power of minus 3 into 5 minus n electron, right? So 5 minus n electron. Okay, so when we calculate this and this will be cancelled, right? This and this will be cancelled. So here 36 electron, I just bring it in this way, 36 electrons equal to here 9 into 5 minus n electron, right? So if we bring in this way, here 5 minus n equal to 36 divided by 9. So here how do we bring it here? 9 ones are 9, 9 fours are 36, right? So here 5 minus n equal to 4. So that means n equal to 5 minus 4 equal to 1. We got that 1. So what is it? Nth power, it is plus 1. Right? It is 1 only. See, oh, indirectly they are asking that question. It is going around the neck. See, usually we only will find that what it is. Directly this is what it is, indirectly they are asking that question, so we used to follow direct questions only, but here in this question indirect way we are finding. I hope you got the clarity about all these questions. Equivalent mass of what it is, oxidizing agent is equal to equivalent mass of reducing agent. That is actually what it is, equivalent mass of K2Cr2O7 equal to equivalent mass of x, that is nth factor, right? N plus, right? Hope you got the clarity. Come on, let's go to the next question here. And this point, what was the H2C2O4 oxalic acid pose? H2C2O4 2H2O, molecular mass it is 126 gram per mole, they only have given, should be dissolved in water to prepare 250 ml of centi-normal solution which act as a reducing agent. See, indirect question only these are all. Come on, let us check. This is also very easy normality question. Indirectly they are asking this question. Come on, let us find this question. Here given mass, in this question we have to find that given mass. Okay, so given mass, how to identify? So given mass equal to number of moles into equivalent mass into volume in liter. That's all. This is the statement to find that answer. This is the statement, that is formula to find the answer. Okay, now in that one more point they have given centi-normal solution. So centi-normal solution, normal solution. So centi-normal solution is actually what it is, centum. You remember centum, centi, that is 1 by 100. Centum, no, 100 out of 100. So 1 by 100 means what it is, 0.01. So that is n. Normal, no, so that is, so n, normality. Oxalic acid, H2C2O4. It gives CO2 plus 2H plus 2 electron, right? Okay, now in this point 2 CO2, here 2 CO2 plus 2H plus 2 electron. So n factor of this reaction, so n factor of this reaction. So here actually n factor of this reaction, it is what it is, 2 electron, right? So 2 electron, that is 2, right? So in this point equivalent mass, it will be easy for us. So equivalent mass equal to molecular mass divided by n factor. So molecular mass of oxalic acid 126 gram per mole, right? And n factor, it is 2. Number of electrons change, it is 2. So naturally what you will get it, 63 here 63 gram per mole, you will be getting for that equivalent mass, right? Okay, 63, you got it. Now we are going to check with that what it is, normality. So here centinormal solution they have given. No, centinormal solution, how much it is? 0.01 n, we found that there. No, so normality we have to identify. Normality, so normality equal to mass, that is given mass we have to identify. So give mass divided by equivalent mass into volume, volume in liter, right? Now this is the another statement. Normality equal to mass, that is a given mass. Okay, given mass by what it is, molecular mass. No, given mass by equivalent mass, because they are asking that what it is, given mass. No, normality, usually normality equal to mass, that is given mass by equivalent mass into volume in liter. This is another one more statement. So normality equal to normality, how much? Normality equal to 0.01 n. Okay, now equivalent weight, that is equivalent mass equal to 63 gram per mole, right? Equivalent also we can write it. Right, now next one, substitute this value. So mass equal to mass, that is given mass equal to 0.01 into 63 into 0.250. Why I put 0.250 here? Given mass, we just bring it here. So when we are bringing this point out, see, when we are bringing this point out, right, so this will be multiplied. So normality 0.1 and equivalent mass 63, and volume in liter, volume they have given 250 ml only, so we converted into liter, that is 0.25, right? So that means what is the value you will get when you calculate together? So here 0.1575 gram. Why I put it gram? Because given mass we are finding out. So 0.1575 gram. So in this, what is the answer we are bringing here? See, the option it is B, the option B, right? Okay, so 0.1575. I hope you got the clarity. How do we bring it? See, equivalent mass, if they are asking equivalent mass equal to molecular mass by n factor, but here in this question indirectly they are asking about normality. When they are asking about normality, directly we can go for n factor. So how do we identify the n factor? That is loss of electron only, loss of electron or gain of electron, in that way. So in that point we just bring it this idea. What is this idea? Equivalent mass equal to molecular mass by n factor, and normality equal to given mass by equivalent mass into volume in liter, in that way. And one more statement, I just bring it to you. So directly we can go for number of moles into equivalent mass into volume in liter. That is the way also we can go for given mass statement. So given mass, how do we identify? I just bring that formula for you. Given mass equal to number of moles into equivalent mass into what it is, volume in liter. Here normality also you can utilize instead of number of moles. I hope you got the clear idea about these concepts and all. Come on, let's go to the next question. These two questions are JEE mains questions, something what it is, away from the track, that is a little higher level, like what indirect questions. Come on, let's go to the next question. Equivalent mass of the salt KHC2O4, H2C2O4, 4H2O, when it acts as a reducing agent. This question also something interesting and important question, indirect question, like we can make it. So here KHC2O4 and here H2C2O4, H2C2O4, 4H2O. See, as we observe here, one hydrogen which is replaced by K plus, right? So this is also what it is, potassium bioxalate, here oxalic acid, right? So here 4H2O they have mentioned here in this point, 4H2O they are mentioning. So in this, which is acting as a reducing agent, equivalent mass only they are asking. Equivalent mass is what it is, molecular mass by n factor. N factor, what it is, number of electrons change. So each oxalate, usually when we are talking about oxalate ion, so C2O4 2 minus, so C2O4 2 minus, when we go for it, 2CO2 plus 2 electron, it's common, 2 electron only. So whether it is hydrogen is replaced by or not, that is not a matter. How many electrons it is exchanging? 2 electrons only exchanging. So here also 2, here also 2. So naturally each oxalate ion loses 2 electrons. So each oxalate ion loses, it is 2 electrons only. So in this 2 electron, in this 2 electron, so totally how many electrons lost? So 2 into 2, 4 electrons lost. So equivalent mass equal to equal to, you know very well, molecular mass by number of electrons change, that is n factor, right? So that means here molecular mass capital M by 4. So, which is that? And option m by 4 is the option. Molecular mass by 4. So, this option D is the option. Okay, now next one, correct option. Now, the next one, equivalent mass of divalent metal is W. Divalent means it is 2. Directly, they have given the option. So, mean answer they have given divalent. Okay, so divalent only we can make out that is 2. So, divalent metal W. So, that is 2W. We can keep it. The molecular mass of its chloride. So, see, this is very simple. Actually, one of the mains they asked about this question as we go for PYQ. Okay, now here, this is metal. Metal, it is a divalent metal. This is divalent, divalent metal. Right. Okay, chloride. This is chloride means what it is. See, chloride. So chloride means we have to identify what is the complete idea. Okay, so molecular mass that is divalent, and so that means it is twice. So here 2 into W, that is what they mentioned. So 2 into W. Okay, molecular mass equal to 2 into, here one more point. So molecular mass equal to 2 into equivalent mass. This is another statement. Molecular mass equal to 2 into equivalent mass. Okay, so here what it is, this 2, it is what it is, divalent as I mentioned here. Okay, and valency also we can bring it. So valency or divalent, anything we can bring it. So valency into equivalent mass. This is for valency also we can bring it. Valency or divalent. Valent is nothing, valency only. Right now, come on. So that means molecular formula of chloride. So molecular formula of chloride, molecular formula. So molecular formula, this is divalent means 2 only it will be. So MCl2 only it will be there. So MCl2, so 2Cl. So 2 into Cl. So Cl atomic mass of chlorine, it is 35.5. So into 2, it is 71 gram per mole. Gram per mole. Got it? Okay, so that means what is that point you can bring it? Molecular formula, that is 2W plus 71 only will be the correct option. 2W plus 71. So how do we get 71? This is molecular formula MCl2. Cl2, how do we bring it? Only 2, how do we bring it? That is because of what it is, metal. That is crisscross. When we go for crisscross, this 2 will come here, this one will come here. So that naturally what it is, divalent. So 2W plus 71. Why do we bring it 2W here? Because it is a divalent. See, in the question only, we just bring that answer right over here. So the equivalent mass of the metal W. So divalent means 2W. So 2W plus 71. 71, it is atomic mass of molecular mass of chlorine, right? So which is the correct option? 2W plus 71. I hope you got the complete idea about these questions. These 10 questions, 10 extra questions, and we have gone through all these questions. In this point, in this session, we have gone through complete idea about equivalent mass. How do we calculate it? How do we handle this kind of questions? Hope you got the clear idea about that. And thank you for watching. Thanks for your great support.